Welcome to the first part of our discussion. So for this week, we are going to discuss quadratic equation, and our learning competency for this topic is to illustrate quadratic equation. So specifically, we are going to determine whether an equation is quadratic or not. Now let us first define what is a quadratic equation. A quadratic equation in one variable is an equation of the form ax squared plus bx plus c equals 0, wherein a, b, and c are real numbers and a should not be equal to 0. This is also the standard form of the equation. So this one is the standard form of the equation. Take note of this. Ax squared plus bx plus c equals 0. A quadratic equation is also called a second-degree polynomial equation. So, ax squared plus bx plus c equals 0, the standard form of the quadratic equation. Take note that if the highest degree or the highest exponent is 2, then the equation is called quadratic. So we already have this, that the standard form of the equation is in the form ax squared plus bx plus c is equal to 0. Now, take note that a represents the numerical coefficient of x squared and b represents the numerical coefficient of x and c represents the constant numerical term. One or both of the last two numerical coefficients may be 0, but the numerical coefficient of a cannot be 0. So meaning b and c can be equal to 0, but not the value of a. If b is equal to 0, then the quadratic equation is termed a pure quadratic equation. While if the equation contains both an x and x squared term, then it is a complete quadratic equation. The given table shows example of quadratic and not quadratic equations. Let us study this table. So here are the samples of quadratic equation. Take note that you have here 2 as the degree of the equation. So that is a quadratic equation. This one is also 2. So this is a quadratic equation. The degree is 2. While for this one, the degree of the equation is 2. And the last one, we also have 2. And for the column of not quadratic equation, take note that the degree is not equal to 2. It is either less than or greater than 2. But you may notice that for this example, the highest exponent is 2. Why can't we not consider this as a quadratic equation? Because you have here an operation. So you could still multiply x and 3x squared and to the all terms on the parentheses. To determine whether an equation is quadratic or not, simplify the equation and look at the highest exponent of the variable. So, if the highest exponent is 2, then the equation is quadratic. If the highest exponent is not 2, then the equation is not quadratic. So let us determine if the equation is quadratic or not. X times quantity 2x squared minus 3x plus 1 equals 0. We first apply the distributive property since this can be multiplied. So you have x times x squared is 2x squared and x times negative 3x, that would be negative 3x squared, And then lastly, x multiplied to 1 is equal to positive x equals 3. So writing the equation on its standard form, that would be 2x cubed minus 3x squared plus x minus 3 equals 0. Take note that this is not quadratic because the highest exponent is not equal to 2. Therefore, it is not quadratic. Let us have another example. 3x minus 2 is equal to 1 over x. So let us simplify the equation. We multiply both sides by x. Multiplying now both sides by x. So multiplying x times 3x, that would give you 3x squared. X times negative 2, that would be negative 2x. And now since these are the same quantity, dividing quantity that are the same will be equal to 1. So 1 divided by 1 is equal to 1. Now let us write the equation in standard form. What is the standard form of the equation? That is ax squared plus bx plus c. So 3x squared minus 2x minus 1 is equal to 0. The highest exponent is 2. Therefore, it is quadratic. Now let us determine whether the following equation is quadratic or not. Take note that the standard form of the equation is ax squared plus bx plus c equals 0. Okay, quadratic or not, 3x squared minus 10 equals 4x. I'll give you 5 seconds. Okay, that is quadratic because the highest degree is 2. Next, quadratic or not, 2x minus 5 plus 2 equals 0. Again, you have 5 seconds. The answer is not quadratic because the degree is equal to 1. Next, we have x times x squared plus 3 equals 8. I'll give you 5 seconds to think. And the answer is not quadratic. Not quadratic because if you are going to apply distributive property, x times x squared is equal to x raised to 3. Therefore, the highest degree, or the highest exponent rather, is equal to 3. So it is not quadratic. Another one, x minus 5, the whole quantity raised to 2 is equal to 2. Is it quadratic or not? That is quadratic. Quadratic because if we are going to multiply this or to expand this one, that would be equal to x squared minus 10x plus 25, and that is equal to 2. Take note that we are only looking for the highest exponent, and that is 2. Therefore, the equation is quadratic. Now, I want you to identify which of the following equations are quadratic and which are not. If the equation is not quadratic, you give a short explanation. So I want you to write this down on your math notebook together with your answer. I hope that you learned from this topic. So wait for the second part of our discussion. Again, I am your math teacher. I am Sir Rainier Arellano. Have a good day.